Now moving on to the next question. Remember y prime stands for dy dx. Nothing different from what we've been doing. We'll say y prime is dy dx is equals to y squared plus 1. We can as well put this in brackets to know what we are doing. Now we would multiply both sides by dx to remove the x from here and divide both sides by y squared plus 1. Therefore we will have that to be dy over y squared plus 1 is equals to 1 dx. The coefficient is 1 because we are left with 1 on this side. Now from here what we'll do is we would integrate both sides. Integrating this from our standard integrals, we can do this as 1 over y squared plus 1 times dy. Standard integrals told us that this is equals to the tan inverse of y. Therefore, on this side, this becomes the tan inverse of y is equals to integrating 1 here would have x plus c. Therefore, we can as well remove tan inverse here and take the tan to this side because we want y to stand alone. Therefore, multiplying by tan cancels out this because this is the same as y over tan, which is equals to x plus c. Therefore, multiplying both sides by tan, tan cancels tan here, and multiplying here by tan, we have y to be equals to tan x plus c. In case you are given a value for x, we can as well go ahead. If we are given a value for x and c, we can go ahead to find the particular solution for this if we are given x and c. Now the general solution for this problem is y equals to tan x plus c. Now moving on to this is more like a linear equation. We can as well represent this y as dy dx equals to 2xy plus 3y minus 4x minus 6. We can factor out y from here and factor out 2 minus 2 from this place. Therefore, we'll have the right hand side to be y into, we have y then 2x plus 3 into bracket, and now factoring minus 2 from here, we are left with 2x minus 3. Though multiplying every of them into the bracket, we'll get back to this. Now from here we would separate this by taking this dy dx we have here, dy dx. Now what we'll do here is we'll separate this side by y minus 2 times 2x plus 3. Like we all know, this will multiply everything which is this, and minus 2 multiplies everything which is this. Because this is plus. Because these both have they have the same thing in the bracket. Now from here we would say dy dx. We will divide both sides by y minus 2 and then multiply both sides by dx to single them out. Therefore we have dy over y minus 2 equals to 2x plus 3 then dx. This is that part where we integrate both sides. Integrating both sides, we would have this to be the natural logarithm of y minus 2 equals to integrating this gives us 2x squared plus 3x. Here is 2x squared over 2. 2 cancels the 2, therefore we are left with x squared plus 3x. Now we would raise both sides to an exponent, and that exponent is e to the power of the natural logarithm of y minus 2 equals to the exponent of x squared. Sorry, here is going to have c, a constant, x squared plus 3x plus c. Therefore, we would say this gives us y minus 2 with the reason we said before equals to the exponent of x squared plus 3x times the exponent of c. This exponent becomes another constant. We would have y minus 2 is equals to that constant times e to the exponent of x squared plus 3x. Therefore, because most times this is usually written as an absolute value, we can as well say both sides is plus or minus what we have here. That is this right hand side. We have y minus 2 is equals to plus or minus of c1, then e to the power of x squared plus 3x. Therefore, carrying minus 2 to that side becomes 2 plus or minus c1 e x squared plus 3x. Now, we may be given, we may be asked to find a particular solution. Then c1 becomes 0. Our particular solution for this is 2 plus or minus 0, which is the same thing as 2. Therefore, we'll solve basic equations on separable equations. We'll be dealing with other ordinary differential equations, the homogeneous equations, and the rest of them in our next tutorials. Thank you for watching today's tutorials.